Ever since I took the course How to Make Almost Anything many years ago at MIT, which I'm sure many of you are familiar in this audience, I have been on a mission to reduce barriers to creativity and to make innovation and prototyping in emerging fields more rapid and more accessible through the design and deployment of new tools, general purpose development platforms, and entire ecosystems. In this talk, I will introduce three of my soft robotics works: FlowIO, softrobotics.io, and SleeveIO. And I will also share my framework for how to design and deploy platforms for high impact across fields. In the foreword of the book, The Evolution of Useful Things, there is a quote by Goodman: "Our progress has been largely a matter of inventing new tools and improving the old ones." This was a very profound statement. Is it even possible to make any progress in any field without tools? I think progress without tools is completely impossible, not just in the technical fields, but even in the social sciences. Thus, I would make an even stronger statement to say that tools enable and accelerate progress. But what do I mean by tools? My definition of tools includes three distinct categories: physical tools, such as the plow, pen, hammer, 3D printer, and computer; digital tools, including programming languages, browsers, apps, and the internet; and conceptual tools, such as language, alphabet, equations, and models. Therefore, tools enable and accelerate progress because without physical, digital, or conceptual tools, we cannot make any advances in any field, including in fields like philosophy and history. One type of tool are development platforms. They play two roles in enabling progress. First, by lowering barriers to entry for novice users, and second, by reducing prototyping time for experts. Take, for example, Arduino, an electronics project that 2 decades ago may have required engineering expertise and a week of work in a lab with expensive equipment. Today, that same project could be done in a weekend by a high school student in their living room. Previously, I used to think that platforms alone were responsible for this kind of transformation. But after many years of using, studying, and developing platforms myself, I realized that what enables this transformation are not platforms alone, but entire ecosystems that emerge alongside platforms. Because even if you have the most amazing technology platform, it will not be adopted widely unless there is also a supporting ecosystem around it. Over the last several years, I have created a framework capturing the essentials for what it takes to design and deploy a platform for wide-reaching impact. First requirement is to have a complete technology package, usually consisting of both hardware and software, with intuitive APIs and libraries. The platform should be general purpose, easily extendable, highly user-friendly, and bring value to both experts and novice users. It should also have a name that is both sticky and unique, so that people can remember it, find it easily in a Google search, and also be able to casually talk and write about it. Second, content, to showcase what is possible with the platform, to educate, and to inspire people to unleash their creativity. Third, community and interactions. This includes users, contributors, and institutions, as well as the interactions that happen between them through workshops, hackathons, collaborations, and online. The community is the catalyst and enabler for wide-reaching impact. The larger the community around the platform, the more valuable it becomes to everyone using it, also known as the network effect. Fourth is an online community platform, a website that can facilitate interactions between people where they can ask questions, showcase their work, get help, find collaborators, and seek inspiration. This can either be one large website that provides various capabilities, including forums, wiki pages, direct messaging, blogs, and more, or it can also be a modest website that simply aggregates services from other providers, including GitHub, Instructables, Stack Overflow, and Discord. And finally, a viable deployment model. The platform must be available and accessible to people, and this must happen in a financially sustainable way in order for the project to survive. Consider, for instance, Arduino. It is a general-purpose hardware and software platform that is valuable to not only novice users, but also experts in different ways. You can easily find thousands of inspiring projects and tutorials and millions of users from all backgrounds. There are many websites for the community, and the deployment model has been highly successful in terms of impact. I also identify several feedback loops within my framework. The platform enables new applications, which then inspire additional features, enabling even more diverse projects. Most of those applications are provided by the user community, and the more inspiring projects there are, the more attractive the platform becomes to new users, who then make even more projects with it, resulting in a virtuous cycle. And there are many other such feedback loops, which I cover extensively in my PhD dissertation. I will now talk about the platforms and ecosystems I developed in accordance with this framework, starting with FlowIO. FlowIO is the first fully integrated and general-purpose miniature pneumatics development platform for actuation, sensing, and control of soft robots. FlowIO is a complete package consisting of fully modular hardware with over 15 modules and a complete software stack that is intuitive and user-friendly. The basic device has 5 pneumatic ports, each capable of inflation, vacuum, release, hold, pressure sense, and flow rate variability. FlowIO has many connectivity options, including Bluetooth, USB, I2C, and others, shown on the right. This platform is comprised of magnetically connected modules that can be swapped within seconds to satisfy different application requirements. There are 3 different kinds of controller modules with different pneumatic multiplexing capabilities, and 5 pump modules for different pressure, flow rate, and portability needs. These modules can be swapped within seconds to allow many different variations of the device depending on the application needs. And as I also demonstrate in this video, you can continue using the device immediately after swapping operation without even an interruption of the Bluetooth connection, since each module is independent. The standard controller module contains 7 valves in a manifold configuration, 2 custom-made circuit boards, a microcontroller with Bluetooth, a battery that powers the device, and even an integrated battery charger. It also integrates about a dozen different sensors, including proximity, light sensor, and even an IMU, and all of this fits inside a compact, 3D printable snap-fit enclosure. The small pump module contains 2 pumps, battery, PCB with power electronics, and another integrated battery charger. Thus, you have a fully integrated solution requiring no external pressure or power sources. The entire device with the small module weighs just over 100 grams and can fit even in a pocket. In addition to the main device modules, there are 5 expansion modules that further augment the capabilities of FlowIO. Those include Vibrotactor driver module, analog in module with 16 analog input channels, buttons module offering 5 programmable buttons, extra sense module which provides many additional sensors, and a breakout module that gives you access to 14 pins. Finally, there are accessories for wearability, mounting, and reconfiguration. Those include a wrist strap for wearability, removable magnetic base, wheels for locomotive applications, enclosures of different colors, including transparent ones, as well as tubes and splitters for changing pneumatic configurations. Here is the pneumatic circuit and a cartoon representation of a FlowIO device in the general configuration. There are 7 valves and a pressure sensor connected to a manifold line, including inlet and outlet valves. Pump 1 is used for inflation and pump 2 for vacuum, and switching the configurations takes only a few seconds by repositioning the tubes. And some of the other configurations include series inflation, series vacuum, parallel inflation, parallel vacuum, a split configuration, extra sense, a closed loop configuration where the same air can be recirculated, and a closed loop with accumulator, which is useful for buoyancy control applications in submersibles. This table shows the pressures and flow rates for some of the configurations and modules. The range is from -25 to +30 psi, and if even higher pressures are needed, then the pump module can be replaced entirely with another pump module that you create yourself, or even a compressed air tank to handle pressures up to 5 bar. Let's now translate from hardware to software. FlowIO includes a device stack and a web stack, pneumatic APIs, and a user-friendly graphical user interface, suitable for both technical and non-technical users alike. The GUI is accessible with a web browser and is compatible with any device and any operating system. Moreover, because it runs in the web browser, no downloads or installations are required to start using FlowIO. To control FlowIO, you simply access the FlowIO dashboard through the softrobotics.io website, and there is no setup required other than making an account and registering your device. The interface supports both open-loop and closed-loop control options. Task scheduling is also possible, as shown on this example, and users can create a sequence of any number of tasks to be executed. An interactive graphic shows the state of each internal component of the connected FlowIO device in real time. In addition to the graphical user interface, you also have the option to control FlowIO programmatically using the included libraries, either through Arduino or JavaScript code, or even through Python and Unity. Shown here are the device stack and web stack for FlowIO. Users can control FlowIO from any layer of these two stacks. At the bottom of the device stack are driver APIs, which control primitive pneumatic components. Second layer is pneumatic API containing methods that control entire activities involving combinations of components. Next is a command API allowing FlowIO control using 3-byte commands. The fourth layer is BLE firmware, where all of the features of the FlowIO device are abstracted into a set of 7 Bluetooth services with 15 different characteristics. And then the web stack also has 4 layers. It is hosted on a web server and is accessible through the softrobotics.io website. Layer 2 is a JavaScript-based web API implementing Web Bluetooth and allowing connection to FlowIO directly from your web browser. And a unique feature of this layer is the ability to control multiple devices simultaneously, up to 7 of them. Layer 3 is a web-based graphical user interface. And finally, we have a peer-to-peer networking layer, which is still in progress, to allow FlowIO devices to connect to each other over the internet for remote collaboration and remote telepresence applications. The common denominator between the device stack and the web stack are the Bluetooth services and characteristics. Other notable features of FlowIO include an auto-off timer, a battery level indicator, real-time pressure indicators, and a power-saving algorithm that exploits the difference between actuation current and holding current. The second project I will discuss is the softrobotics.io ecosystem, which is one manifestation of my framework presented earlier. Softrobotics.io extends the FlowIO platform into an entire ecosystem for prototyping and creativity, with soft robotics and actuated materials. This ecosystem aims to deliver everything that a maker, designer, or a researcher in the field needs in order to be able to realize creative projects quickly and without frustration. Softrobotics.io includes a family of integrated development platforms with different actuation approaches, including pneumatic, hydraulic, thermal, tendon-based, electromagnetic, and electrostatic. And FlowIO is just one of these 6 platforms. And the other platforms share much of the same hardware and software that is used in FlowIO, just with different type of actuators inside. Hundreds of people have now used FlowIO for countless projects across many fields. Those include haptics, art, wellness, education, robotic surgery, interaction design, telepresence, assistive technology, gaming, and much more. Each circle is a project that was made with FlowIO. For instance, here is a wearable system that enables grasping without bending of the fingers. Another project is OmniFiber, a reconfigurable fiber technology for designing movement-based interactions using thin fluidic fiber actuators with strength control. It enables designers to seamlessly create tangible interfaces with the fibers. Three Voices is an opera performance that augments the listening experience with tangible interaction. It uses OmniFiber and 18 FlowIO devices that are synchronized to the rhythm of the music to deliver haptic feedback to listeners and enable a very immersive listening experience. New Bots is a modular construction kit for playful exploration of soft robots, consisting of 7 types of self-foldable segments with high tensile strength. The kit enables various assemblies to be made with the modular pieces, allowing people to explore soft robotics in playful ways. 1001 Flowers is an interactive art by students from Harvard Graduate School of Design. And we even had a FlowIO device go to a zero-gravity flight. Peristaltic Suit is a project from MIT to mitigate the effects of prolonged exposure to microgravity environments. The platform has also been used in many master's and PhD dissertations. A major emphasis was placed on creating and fostering community and interactions between people, both in person and online. And some of those efforts have included collaborating with users on their projects to help them, organizing and hosting workshops, just like this one today, providing resources for other workshop organizers, as well as working with professors who are using this platform as a teaching resource at various universities like Harvard, MIT, ETH Zurich, and others, including in the How to Make Almost Anything course at MIT during the Wildcard Week, which I TA'd for a few years. This community aspect would not have been possible without the softrobotics.io website serving as an online community platform, where people can post their projects and experiences, ask questions on the forums, find collaborators, read tutorials, request a device, and much more. More than 30,000 people have visited the website from nearly every country, and of those, about 1,000 have made an account. This brings me to the last component of the ecosystem, the deployment model. FlowIO is an expensive device, and most people cannot afford to buy it. Therefore, to democratize this technology, I came up with a deployment model where one can obtain FlowIO regardless of their financial situation. I introduced a hardware sharing program where people can obtain FlowIO free of charge for a limited time in exchange for some type of contribution that benefits the ecosystem. Contributions can include hardware or software development, writing tutorials and documentation, making YouTube videos, helping with fundraising, or anything else that helps the project and the ecosystem grow and evolve. In this way, any contribution made to the project benefits the entire community of users, including the one making the contribution themselves. And if someone wants to keep the device long-term, they can then purchase it. And those proceeds then help cover the operating costs for running the ecosystem and for enabling the hardware sharing program. The model was inspired by studying various deployment models, initiatives, and philosophies from other projects. And it was also very strongly motivated by 2 of the 4 requirements in the Fab Lab Charter. Number 1, stating that a Fab Lab is about democratizing access to the tools for personal expression and innovation. It must be open to the public for free or in-kind service, at least part-time each week. And number 4 of the charter states that Fab Labs must participate in the larger global Fab Lab network. You cannot isolate yourself. And so both of these elements in the charter are tightly present in this deployment model where people can obtain FlowIO free of charge for a limited time and where they must contribute to the broader community. And finally, I'll talk about SleeveIO, which is a haptic feedback platform I developed during a research internship at Meta Reality Labs, which is now open source and powered by FlowIO as well. In the world of consumer electronics, different types of devices are usually compatible with one another, regardless of their brand. If you are an interaction designer trying to build a new user experience that incorporates several types of products, you can quickly interface them with one another because they use shared standards for connectivity and communication. But now suppose you want to create some user experience that integrates different kinds of wearable haptic technologies. You will find it nearly impossible to combine them unless you spend an enormous amount of time to modify the hardware, invent new connectors, and to develop custom communication protocols. But what if we had a way of combining different types of haptic feedback projects just as seamlessly as we can combine different types of consumer electronics? To achieve this goal, I focused on 4 key areas: modularity, being able to add or subtract components as needed; reconfigurability, so that the modules can be arranged and positioned arbitrarily; support for many different types of haptic actuators; and support for different kinds of actuation approaches that are commonly used in haptics. If we can achieve all 4 of these characteristics together, then we have a fully general-purpose solution for wearable haptic feedback interaction. And prior to this work, there were no projects in the haptics literature with all 4 of these characteristics combined. This 4-part approach towards compatibility between wearable haptic technologies is what led to SleeveIO platform. SleeveIO is a fully modular and reconfigurable wearable platform for rapid prototyping and testing of multimodal haptic feedback interactions. SleeveIO features a diverse set of haptic actuators of many different types, behaviors, and actuation approaches, all sharing the same kind of magnetic connection mechanism, and powered by a single control system, FlowIO. The actuators can be connected in numerous configurations on knitted substrate within seconds, enabling users to rapidly create diverse haptic experiences with SleeveIO. SleeveIO features machine-knitted substrates, magnetic couplings consisting of 3D printed poles and caps, 5 types of haptic actuators that attach magnetically, control hardware for pneumatic and electromagnetic actuation and sensing, and a software stack with a user-friendly graphical user interface and libraries. SleeveIO is fully wearable, portable, and untethered, and it does not require any external hardware or software for power, actuation, or control. 2 types of machine-knitted substrates were created for wearability on the forearm: a sleeve that covers the entire forearm, and a set of bands that can be positioned anywhere along the arm. The sleeve is suitable for actuators that don't require direct skin contact, while the bands allow actuators to contact the skin directly. The sleeve mesh was machine-knitted using the pointelle pattern with 1 mm diameter holes, offering a wide degree of stretchability, up to 50% longitudinally and up to 100% in the transverse direction. 3D printed poles can be inserted through the holes of the mesh anywhere on the knitted sleeve or band, enabling arbitrary reconfigurability, just like a breadboard. The poles have a magnetic top to which we can then connect any kind of haptic actuator. The poles serve 2 distinct roles: first as anchor points for any haptic actuator, and second as carriers of haptic signals, including shear, push, vibration, tilt, and rotation. The coupling mechanism also includes a magnetic cap with 2 versions: a circular version that provides rotational freedom, and a square version that constrains any rotation. SleeveIO features 5 types of haptic actuator module: vibrotactors that use the poles as signal carriers, bellows that act directly on the skin, muscles capable for both shear and vibration stimuli, a cup actuator suitable for suction and puff, and a quad chamber acting on up to 4 neighboring poles. We can arrange the actuators longitudinally, radially, or in a grid pattern. The quad chamber is a new type of actuator developed specifically for this project, and out of silicon-based structure and several 3D printed parts. This module alone is capable of delivering 14 different stimuli, including directional, vibrational, rotational, and linear. We conducted pilot studies with each type of actuator to assess the viability of SleeveIO and our coupling approach, therefore validating that SleeveIO is a viable haptic feedback platform. The user study results are summarized in these snowflake diagrams, which can help also interaction designers to quickly be able to decide what type of actuator module is best suited for what type of application. For details about the methodology and the user studies and the actuation patterns used, please refer to the paper. So these are all of the people who have contributed to the SleeveIO project to make it possible. And here are some of the hundreds of people who have helped with the FlowIO platform and the SoftRobotics.io ecosystem. Thank you.
Thank you so much, Ali, for showing us this amazing work about soft robotics. I think that is very impressive. And that's why we wanted also to invite Ali to be here. Actually, he's finishing the PhD. So we want to ask the public if you have some questions about the presentation. So if you want to have the chance, just go ahead.
One question about the hardware. You said it's difficult to, well, it's expensive somehow. And you can also go through the software. So we build such a model, maybe. But if an institution wants to buy the model, the pumps, all that, I know that there are somehow available some parts, but I tried to get them like a year ago, and it was very difficult to get them. Is that now a possibility?
Yes, so there have been some changes and updates since a year ago. So some of the components I now am providing on. I have now created an online shop where people can obtain some of the more difficult to obtain parts. So that's one change. Still, the fully assembled device is not available, not there for sale due to the high complexity involved in the assembly process. But that's also something that will likely be happening in the near future as well.
Okay, but for example, if my lab wants to work with the iFlow, we have to build it. Yeah, let me know the best way to have it.
Yeah, so at the moment there are a number of devices that are part of the hardware sharing program, and when a user no longer needs the device, then that device becomes available for borrowing. So that's one way of obtaining a FlowIO device if there is one available, and the other way is to build one yourself. And kind of the goal here is that as more people build these devices and as they make them available to be part of the hardware sharing program, there would be eventually more and more of these that are also for borrowing. But I would also say that even in the assembly parts, I have been developing over the past years a number of simplifications. So the assembly process has gone from taking about a month to now about half of that time, and it's still being made easier and more convenient. And now what I have on the online shop is the circuit boards pre-assembled. So all of that soldering is no longer even required. So there have been gradually incremental improvements to making this more and more easy for people to obtain.
Okay, thank you.
Mm-hmm. If you have more questions. We can have this question and just briefly because we want to start with the hands-on. Okay, yeah, please go ahead.
Yeah, so I help host a robotics group in Houston on Saturdays, and we have a lot of kids who are really interested in like getting into robotics. I'm wondering, is there resources, I guess like lesson plan or some sort of things like available on soft robotics that are kind of geared more towards like introductory kind of beginners getting into robotics?
Yeah, that's a great question. And so this is indeed one of the aims of the SoftRobotics.io website, to be this platform where people can not only find resources, but also post resources. And so some of the workshops that I have co-hosted in the past years have generated a number of tutorials that have been posted on that website. And as more workshops, just like today's workshop, are created and posted on that website, eventually there will be a growing repository of these resources, tutorials, documentation, and the like. And those things don't necessarily have to be related to FlowIO. That's not the goal. The goal is to have a very general purpose website for anything having to do with soft robotics, programmable materials, actuated materials, and all of those. And so right now, if you go under the community tab in the softrobotics.io website, you will find there probably about 24 posts from people. Some of those are tutorials, some of them are people discussing projects they have created, some examples, and it keeps growing over time.
Yeah, I have to compliment that we have the website, you can put in the computers, is the website of this workshop. We really try to document in that way that everyone has access to the tutorials we do. And yeah, Ali offered us to the repository to publish the things there. So, and are very like easy tutorials that I hope you can of course replicate afterwards. And yeah, so in the past we have also 2 workshops in a high conference, in a conference that are more scientifically oriented, but also with some tutorials and papers that that invite you to explore, because it's a really good work and a start from easy to complex. Yes. Also, we have the FlowIO here because we have, as I said, 2 sessions, fabrication and actuation. So we will have the chance to play with the platform with your soft robotics, and I hope that one of the groups or the individuals that wins can also, of course, use it, but also, of course, all the other possibilities. Okay, so thank you so much, Ali. We will continue. And yeah.
Okay, have a good rest of your workshop. All the best.